All right, so here's number 34, and at first I thought number 34 was going to fall into the whole antiderivatives that we don't care about taking portion of this, but in fact, forgot that it was a calculator question. So the fact that it's a calculator question is going to be very easy to do. So we're given tan squared x over x squared plus 1. We're given that that's a derivative. We want to find f of 0. So probably the first thing we should do is establish the fact that if this is what we're trying to find, this is a fundamental theorem question. You're told f of 1 is equal to a half. So kind of like the accumulated area when you get to 1 is equal to a half. So I'm going to say that f of 0 is equal to f of 1 plus, now we're going to take the antiderivative, but we're going to go from our starting point of 1 to where we want to end up, which was 0, of the function that we're looking at, which is tan squared x over x squared plus 1 dx, of which that is a hard antiderivative to find, even with trig substitutions into that. I do know that f of 0 is equal to f of 1, which is a half, plus this antiderivative, but this is a definite antiderivative that your calculator can take. So you're just going to math 9 that and throw in tan squared x over x squared plus 1 in terms of x between 1 and 0, and it should spit out the number negative 0.34464. And when you add those two values together, f of 0 is equal to 0.15536. And I believe that the answer is the one that's 0.155, because in calc we go to 3 decimal places for our decimal approximations. So, think back to our fundamental theorem problems where we had this initial condition of f of 1, and then we're adding to it from 1 to 0 because we're trying to find f of 0. If we were trying to find f of 7, it would be from 1 to 7 of that, and then you're going to let your calculator go ahead and evaluate that for you because it is a calculator question. All right?